Our last big topic here is going to be mass percent composition. And our objectives here are to calculate the mass percent from a substance's chemical formula. And then if we know the mass percent composition, to figure out how much of a sample is a particular element. Like if we know that 25% of our sample is silicon, how many grams of silicon does that equate to? The most general formula I know for a percent is to say that a percent is a part over a whole times 100. Any percent can be somehow cast into this formula. In the case of chemicals and the mass percent composition, since that term mass is in there, we're going to be working in grams. The part is going to be the mass due to an element. And the whole is going to be the mass of the whole compound. So that's also what we've been calling the molar mass, because when we add up those numbers from the periodic table times the subscripts, that is giving us the mass of the whole compound. So we're going to stick the molar mass in the bottom. We're going to stick the mass due to an element in the top. That's a little more complicated than just the mass of the element from the periodic table, because we're going to also have to multiply times the subscript. So we're going to get a number from the periodic table and multiply that times the subscript to get the total contribution from that element. Then after we take that ratio, we multiply it by 100, and that gives us that mass percent. So I tried to write that out a little more formally here. The mass percent is the mass due to that element over the molar mass times 100, and we can substitute in the top there that it's the subscript times the element mass. That's what we're going to get from the periodic table. So the subscript from the formula times the mass in the periodic table, all divided by the molar mass, and then that ratio is multiplied by 100. So let's try this one. Let's find the percent by mass of fluorine in carbon tetrafluoride. The formula for carbon tetrafluoride, that tetra prefix, that's telling us that we're doing covalent or molecular compounds, right? Because carbon's a nonmetal, and fluorine is a nonmetal. Nonmetal plus a nonmetal is covalent or molecular. The numerical prefixes tell us our subscripts. So that's going to be CF4. So I'm going to, there's so many different ways I could set this up. I'm going to calculate the molar mass first, since that's going to go on the bottom. I'm going to calculate that up top here. We're going to have 1 times 12.01. That's the carbon part. Whoops, that's not an equals. I wanted a plus there. So 1 times 12.01 plus 4 times the mass of fluorine, which is going to round to 19.00. And running that through my calculator, I'm going to have 12.01 plus 4 times 19. Again, I didn't type the 1 into my calculator because it doesn't change things. That ends up with an 88.01. All right, let's break this down. That 1 times 12.01 is the mass due to carbon. The 4 times 19 is the mass due to fluorine. And then the 88.01 grams is going to be the mass of CF4. So to find that percent by mass of fluorine, we're going to take the mass due to fluorine, which is going to be 4 times 19. Again, the 4 is the subscript in the formula. The 19 came from the periodic table. We're going to divide by the molar mass, which is 88.01. We're going to multiply by 100 because it's a percent. So I can take 4 times 19 divided by 88.01 times 100. And that's going to give me 86, let's see, let me go ahead and keep sig fig straight. So that's going to be 86.35%. That 19 I got sloppy on. We really do the masses to 2 decimal places when we're doing molar masses, so I should have written the 19.00. That's going to have 4 sig figs. The 88.01 has 4 sig figs, and then the 4 is a defined number from the formula for the compound. Sig figs don't apply, so we're going to keep 4 sig figs in our final answer, and that's telling us that this compound is 86.35% fluorine. All right, let's take a look at the next slide. This one is asking us about the same compound, carbon tetrafluoride, but now it's asking us about the carbon. So we can go through a very similar process to figure out the percent by mass of carbon. We found on the previous slide that the molar mass was 88.01 grams. So that's for the whole thing, the CF4. So if we're going to find the percent by mass of carbon, that's going to be the mass of carbon. Well, there's only one of them, and it has a mass of 12.01. So the numerator there with the mass of carbon is 1 times 12.01. The denominator is the mass of the whole compound, or the molar mass, 88.01. And then we'll multiply times 100. And so that's going to be 12.01 divided by 88.01 times 100. And that's going to give us I think I did something wrong. Let's see. That's going to give us 13 point. No, I'm good. That's going to give us 13.65%. All right. So here's what I was looking at, but I looked at the wrong number, which made me think I might have had made a mistake. But then I found the correct number, and I was like, okay, we're all good. So the way that I was checking this is when we calculated the percent of fluorine in the previous problem, we found that the percent of fluorine was 86.35. So I could have arrived at our answer for the percent carbon by a little bit simpler path. Since there are only 2 elements in this compound, their percents have to add to 100. So knowing that fluorine was 86.35%, I could have found carbon by taking 100 minus 86.35, which would have given us the 0.65 and the 3 and the 1. So 13.65% carbon because it was 86.35% fluorine. Those 2 percentages have to add and give us a 100. Okay, one last example after this one. So often if we know a percent, we may be asked to find what the actual mass of an element is in a compound. So in this case, we've got 37.2 grams of carbon tetrafluoride, and we're asked to find what's the mass of fluorine in that sample. But we've already calculated that this compound is 86.35% fluorine. Now, this is a calculation that I have seen students do all sorts of different ways. And it really depends on what your math background is and how you are comfortable doing percentage problems. The way I was taught to do a problem like this was to convert my percentage to its decimal form, right? So if you have 50%, the equivalent decimal form is 0.5. You move the decimal 2 times. If you have 25%, it's 0.25. So in this case, the equivalent decimal would be 0.8635, and then multiply that decimal times the total sample, which is 37.2 grams. And so if I take the weight of that whole sample, 37.2 times 0.8635, I get 32.1 grams of fluorine in this sample. So that's one way to do this. Another very common way that I see people do this is they'll say, okay, 86.35% means 86.35 out of 100, and that has to be equal to the same ratio for our compound. We're looking for the mass of fluorine, so that's the top part, and the mass of the whole sample is 37.2, and then students cross multiply and divide, or actually on this one all you have to do is multiply times 37.2 on both sides, right? So times 37.2 and times 37.2. The 37.2's cancel out on the right, and x is 37.2 times 86.35 divided by 100, which is the identical math to what I did up above. So x is equal to 32.1 grams of fluorine. There are so many different ways you can do this. If you're comfortable with percentages, and so your approach to percentages looks a little different than mine, as long as you're good with your approach and it is giving you the right answers, that's totally fine for you to use different approaches on these types of percent problems.